So, um, in the next part, so we'll directly switch over to the next part of our tutorial now. And this is, as I said, about not just showing examples what can be done in Unreal Engine, but really to show how this can be done. So for this, our next speaker will be Patric Ljung from Linköping University in Sweden. So may I already ask you, so to say on our virtual podium, Patric?
Thank you very much for inviting me. Do you hear me?
Yes.
Very good.
I can hear
Thank
perfectly. So a few words also about Patric. He is a senior lecturer in immersive visualization in the division for media and information technology at Linköping University in Sweden, as I said. And he's also a research coordinator at the Visualization C Center, if I'm not mistaken. And yeah, his current research involves immersive visualization and yeah, what may be also interesting is Patric also had a connection to industry before, so to say, coming back to university. So he worked as a project manager at Siemens Corporate Research in Princeton between 2007 and 2013. And I'm not sure if they also use game engines there, but right now he obviously is a big fan of Unreal Engine, and we're very curious what you can tell us about using the engine. So, stage is yours. Thank you.
Thank you very much for the introduction. It's very exciting here to see the previous talk as well, what's being done using the Unreal Engine. My plan was to start off here, and I will try and share the right screen, plus enable it for sound and screen sharing video clips. There we go. And did I get the right screen now? I hope so. Let's move this out of the way. And off to the presentation. So double check everybody's seeing this presentation here. And yes, so thank you very much, Michael, for inviting us to host this little tutorial on game engines for visualization. My name is Patric, and I will talk more about the Unreal Engine and how it looks like and what it feels like and what you can do. Some of the concepts involved and working with such an platform. Xavier will follow up, talk more on the Unity platform and his experience using that. But I kind of my first task here to make a motivation for why you should use a game engine was really helped by the TWT talk, and Caroline gave a nice introduction also to the work. But I see a lot of segments today that are embracing the game engines, such as architecture and urban planning, automotive and transportation, like you see in the image here, maybe. Even for broadcast and live event, film and television. You may have heard of virtual production and mixed reality setups. But even municipalities and government agencies are embracing game engines to communicate their plans and so forth. It's also being used in education and for museums and science centers, which is really exciting. And to me, these game engines are kind of an operating system for interactive 3D worlds. You bring both the geometry, meshes and stuff, but you also packages with logic and game logic or application logic or what not. And more people, colleagues at the university and academia are making things to help in education and so forth. And of course, that's a game engine is then their platform of choice. And of course, we need to be able to bring our data visualizations into these worlds. Cannot always be expected that, well, we have this software, but you have to go to this desktop and use it when they already have a 3D world or a virtual reality with a head-mounted display, for instance, to show up things. And as you also saw in the previous talk, I mean, game engines has a lot to offer for data visualization. And one thing to keep in mind is that there's a lot more to the ecosystem than just the game engine. We have all these content creation tools and all various software packages and things like City Engine, FME from Safe Software, Revit, SketchUp, enabling you to bring a lot of content into a real-time environment, such as Unreal and Unity. Recently, a little plus side here on the Unreal side is that the joined with Quixel, or brought them in on the team. So all the Quixel mega scans, Quixel is a company with the philosophy or mission to scan the world. So there's a lot of free assets that you can use for free with the Unreal Engine. And also Twinmotion is a visualization software that was developed by Advent in France, I believe. I was also acquired by Epic Games recently. It was already building on the Unreal Engine to begin with, but so that's a lot of things available to you. And of course, both Unity and Unreal supports pretty much all the platforms like Switch, Xbox, PlayStation 5, etc., etc. So that's a little bit a plug for the motivation. A lot of other people are using this, and of course, we would like to be able to offer various data visualization techniques that we've been accustomed to, but often in our own other software packages, which is mostly used by visualization people, so to speak. So in this first part, I will give you an introduction of the Unreal Engine and a few examples, and then I wish to go through a couple of engine key features and what is an engine. Some of this probably are very similar to what's been found in Unity as well. I like to see maybe a difference between the Unreal Engine and Unity is Unreal Engine comes with all the bells and whistles packaged and enabled by default, which also means that it's quite a lot to take in. Whereas Unity is more of a, how should I put it? You don't have everything turned on to begin with, and not all the plugins are there. You'll have to bring them in, but there is a larger market of third-party plugins and things for Unity. So after going through some of the overview concepts for the Unreal Engine, I will look into the blueprints, what's mentioned previously as well. So that's a visual style of programming. It's very good for a number of reasons. Prototyping is one, and also game logic and so forth. Heavy-duty processing is maybe not where it shines, although it is pretty fast. Another concept that's also important to go through is materials and how they work and what they are. They are very much an integral part of the whole rendering pipeline. Also promise to go through a couple of things and see how it looks like from a C++ programming side, which is also very interesting. And wanted to conclude a little bit of some development experience that we have and a summary, and then we have time for some questions and answers at the end. Hopefully I can answer one or two questions or so. So I wanted to start off with a couple of points or just showcasing a little bit of what can be done with the Unreal Engine. But first, a few things about it. Of course, you've kind of seen this, but it's been 20 years in the making, a little bit plus now. Really support AAA graphics for high-end games, support storytelling, handling of media, interactivity, collaborate both in the editor to create worlds, but also online multiplayer games and so forth. Deployment to various platforms, and also a very strong focus on the enterprise segment since a couple of years back, when they started the enterprise part of Epic Games as well, addressing the needs from everything but games. And as been mentioned, it's kind of free and it's open source, although not a BUSD license, but you can have access to the source of the engine, which is both very daunting because that's a lot of stuff in there, and but it's also helpful to see how things can be done and how to work with it. And recently, they also introduced that if you are developing an application that's geared for toward commercial use or to be pitched on the Steam or Epic Games market, you don't have to pay royalties until you're hitting your $1 million income for your title. So that's pretty generous, I think. The one other part is it makes sense to maybe sign up for a Unreal Developer Network support license, and that is going to cost you about $1,500 a year per seat. But in comparison, it's perhaps really not so much money in terms of the kind of help you could get directly from the Unreal Engine developer team. So that's a lot of stuff that's kind of looking awesome. And this is precisely what the Unreal Engine was kind of built to do. But the major question we have is, what about SciVis, InfoVis, or visual analytics, or data visualization, as I may boldly say, to cover them all? What do we have in this community that's kind of not really what's typically going into the engine? A lot of dynamic geometry, creating new geometry based on data, and the ability to map various data to visual representations. We have a bunch of other different data formats that's not part of the standard community of digital content creation. We want to stream a lot of data in and out, or mostly in, perhaps. We want to do deployment of an application without any data. So that's going to be loaded and used up after you have done your development work, so to speak. What's missing more? A lot of examples on how to achieve those things. And of course, tutorials, trying to explain how could you possibly do things, or how do you get to know what can be done. So the next couple of few slides are going to show you small clips of more data viz or scientific visualization stuff that I've seen being done with the Unreal Engine. And of course, you may have a bunch of your own examples that's I have not seen or so forth. But so this is actually a virtual reality project, a few years old, and it seems that it had been kind of put to rest. I haven't seen any updates in a while, but it still showcased a little bit of what you can do in visualizing proteins and molecules. Next session is going to be about drug discovery, and there's some audio on that one, so I'm not going to speak there. So that was one example, and the next one is from colleagues over at the UC Davis, a former PhD student of Quan Liu Ma, who worked on network visualization in the Unreal Engine and how to map that onto for a user on how to watch. Another case here is from another virtual reality challenge that was put out a couple of years back. And how do you pack a lot of information? And they had the idea of spiraling the actual data set here around a spiral and then cylindrically wrap that around the user who would be in the middle here and manipulate this kind of data. And that's a lot of, or some examples, but many things that are important. And I work at the Visualization Center C as well in Norrköping at Linköping University. So science communication is, of course, one very interesting field, and being able to build stories and tell about science in various forms. So I have a couple of clips here that shows you various projects that I've gathered here. Right, so that was one example from a couple of years back. Another thing that I found very interesting is the use of mixed reality for live broadcast. And a couple of examples that you may have seen is from the Weather Channel. Right, so that was an example from the Weather Channel, and they've done several of these different types of things. Of course, we have a dome in Norrköping, and one of the challenges or big questions for us, can Unreal Engine do dome rendering? That means clustered rendering. And we recently got an upgrade to the latest NVIDIA RTX 8000 cards on 12 of our machines driving the dome. And right, so we didn't do that. But the end display plugin feature now allows us to actually use the Unreal Engine in our dome and in various other multi-display systems. So enough of showcases here from the internet and YouTube, and let's dig into some Unreal Engine schematic overview. And this is a slide that kind of was explains a little bit about all the concepts and things that is part of the Unreal Engine, and specifically in the editor workflow. It's inspired by a talk on the online learning platform from the Epic Games. And Ljung is presenting and giving you a world building schematic here. So if you want more details, you can head over to that one. But essentially, everything revolves around a level. So you have a level and in which is the world outline, and you drag stuff into this level to create all sorts of things like landscapes or meshes, skeletal meshes, which are animated, and you can create procedural meshes and whatnot, as you have in the bottom here of 3D actors that can be placed into a world. Actors is, by the way, the most generic term for, or the base class, so to speak, for anything that can be placed in the world. It has a location and or transform shortly. There are other actors that I have up to the left here, which is also contributing, like lighting, light sources, volumes of various forms, audio, workflow programs or blueprints that control what's going on. You have reflection and reflection captures and gameplay logic as well. So all these things go into the level, and the level can also be organized into multiple sub-levels, which is a very important piece if you are many people on a team working together with something that, say, the audio is placed in a specific audio sub-level, and lighting is placed in a specific or multiple sub-levels. You can have gameplay logic and other kinds of logic also in these sub-levels as well, which means that multiple people can work on it concurrently without interfering with each other. And at this point, I feel maybe a confession here is due. A lot of the content, or pretty much everything that is content-wise, is binary blobs, which makes it a little bit tricky for source control systems like Git. But with the combination of Git plus the large file support, LFS, I found it actually works fairly well. The industry standard, though, would be using Perforce mostly. Right, that was a sidetrack a little bit. And at the top here, we have control. We can do that with level blueprints again, or of course, C++ code. You can make timelines. You have a sequencer that allows you to animate and script cutscenes and what have you. And also creating variants for day, nighttime, and so forth. So the 3D modeling part here is fairly new, but it's coming in as well, that you can do more of modeling in the software. I have that to the bottom left here on my presentation here. UV mapping is a very important part for being able to make these realistic views, as you saw also in the previous presentation here. The whole rendering pipeline is based on high dynamic range, HDR, with a tone mapper at the end. And they're also using physically based rendering, PBR workflow, which requires some specific things as reflection captures to make it look as you want. The rebuilding part up on top here is contains like lighting, computing light maps, simulating indirect lights, and so also capturing reflections, calculating or pre-calculating navigation meshes and navigation, and how to deal with hierarchical level of detail, which is a technique to combine multiple meshes into single larger meshes, maybe of a lower resolution or complexity, in order to minimize the number of draw calls. There is, of course, some of you may have seen the Unreal Engine 5 demo running on a PlayStation 5, which has some new features, which will have an impact on the rendering pipeline in the future version, using mesh shaders and other new techniques to optimize the rendering. So you can go up to about 20 million polygons per frame at 60 frames per second. One important part also, of course, in large worlds are level streaming, ability to programmatically define which sublevels or levels you're going to stream in from time to time as you move around in a large world. There's also volumes and other features that would allow triggering loading of different levels or sublevels. And another very important part is to the end here, performance. There's tons of tools to help you profile and analyze how your project is going and how well it's rendering. Plus the runtime scalability, allowing you to have to deploy for mobile platforms and have built in all the aspects of how would you scale down the shader and material complexity on your mobile platforms, etc. So you can encode and write one project that can be deployed onto several platforms. Right, so that was a little bit of the overall architecture and things in here. Maybe a little reflection here on Unreal Engine versus Unity. There's a little bit of more confined space on how to do things. You have to follow the Unreal Engine's way of doing things. You cannot just hack your way through some GLSL shader code or HLSL. Your shaders and shader code is very core to the parts of the engine. which makes it a little bit more, a lot more to learn before you can write your own compute shaders, compared to what I've heard about Unity. It's easier to go in and hack your own way and just throw things into the gbuffer and have things on the screen. So next up here is a little example in which I was planning to go through what's been done here. And I kind of faked my own little DNA chain. I just have T's instead of the proper geometry that should be in there. And in this, I use a blueprint actor and instanced meshes. We'll explain shortly what that is. So in this little blueprint actor, I do an iterative build of the chain, as you see in the short video on the side here, and also iteratively dissolving that chain, and then also have an iterative cleanup. What I mean with iterative is that I just make a few of these T's or base pairs per frame, 2 or 4, for instance. Then I was planning to also go through a little bit about material creation and what materials are and what are material instances. And if time permits, we can have a look at the sequencer animation and how to make an animation out of this. So that was in the presentation so far. So let's jump into the engine here. And as mentioned here, this is the user interface. Well, one of the many parts of the user interface that you have in the game engine here. So this little scene is, let's see if I can get this to work here. Yeah, can navigate a little bit. Should speed up the navigation so I can move a little bit faster around here. This was first test to actually create a couple of the molecules that constitute our DNA. But the first thing I did was actually a little small molecule here. And that should be, I forgot actually what it was. But so this is a small blueprint, and let's open up the blueprint. Or maybe before I do that, we have a couple of very core assets, as they're called. Everything in the game, on the content here, are called assets that you pull in. And this is a mesh, static mesh actor, and static mesh that I have. Can double click on this guy, see if we can see how it looks like. It's very small, so let's focus on that one. So here you see that's a small little T thing that I created in Blender. Actually, in the middle here, that's where the DNA molecule goes, and this is the kind of backbone of the DNA strand. Very simplified for various reasons. So this is the actual mesh. A mesh can have one or more material slots on them. And that makes for each material slot, it's essentially a submesh that can have its own material assigned to it. In this mesh editor, you can work on setting up the level of detail, simplify the meshes, assign various level of detail settings for the objects and when it's going to switch and how, so forth, and work with these meshes. Another thing that's also very important are, of course, materials. A material is essentially boiling down to a bunch of shader code. And it kind of, let's see here, looks like this. Let's see if let's move this around. So here we have the material applied on a default sphere. I can change from different objects that I want to use here, a plane, got to see it from the other side, or a cube. Or if I have my own mesh, I can select one in the content browser, like in this case. I can select my T, go back here, and then assign that one. Since that one is just a few centimeters large, it's much, much smaller than the other things that you saw here. So let's go back to the sphere. And here we have the sphere. So already in here, you see some of the PBR materials. You see on the grazing angles, you have quite a lot of shine from the custom sky or from the skybox here. So materials, essentially, they give you your base color, the metallicness of your material, the specular, usually put between 0.4 and 0.5 for realistic material, and the roughness. So roughness, metallic, and base color are or albedo. Those are the three major parts of a PBR material if you work with the PBR workflow. And most of the authoring tools like Substance, Quixel Megascans, etc., they provide you with these texture maps, the roughness, metallicness, and base color, albedo, possibly specular, and ambient occlusion maps, etc. So it's kind of a lot of the things are lining up and working to make things smooth and work across various tools. So this is essentially what gives my material the appearance. I don't use any texture to give it a structure in this scenario, but I did play around a little bit with giving it a little bit of this wiggliness, which doesn't really show up on this large because I'm just moving things at or offsetting things at a small scale. 0.15 means 1.5 millimeter, I think, or something. It should be 1.5 millimeter, unless I have a multiplier somewhere that scales it up. So that's the world position. Maybe I should jump back here to the small t here and see how that looks like when I have. So I can then disconnect this guy. Weak links. And now I see how this material is acting without this. So this is just standard and doesn't do anything. Well, so this is essentially a material, and it really boils down to both what you're going to do per pixel level, but the world position offset is something that's done on a per vertex level. So there are many shaders in a way that's, if you're familiar with the traditional shader programming in GLSL or HLSL, where you have the pixel or fragment shaders and geometry shaders. And so a material combines things at several of these parts that you're used to write separately. And just to go through what I did here is I take my world position and then I translate that into a local space for my mesh here. I have the time coming in and I multiply time with a wiggle speed that I called it, how fast it's going to be. So this is a parameter that I've defined for this material. I've also defined a wiggle scale, which is another parameter. It's just a scalar parameter. So I use the wiggle speed to multiply that with time that I have as a built-in data field. Then I multiply that with a vector. So this is just creating a vector 111. And then I add that vector to my position here, such that I get different for each of these vertices. I get a different position in which I use a 3D Perlin noise. So that gives me a 3D vector out. That's going to be some kind of noise structure. And what the time does here is actually moving my positions across through the vector noise here, so that I get temporal variation on how much I offset and displace my world positions on my vertices in this material. So that's one way of creating things. Of course, you can do lots of things, rotate or have rotations and other things that would actually define how your mesh is going to act. So you can use materials to create variations, or think of it as glyphs. If you have a glyph for tensor data, you can actually shape your tensor shapes here in the material. If you have some data to pick up what specific glyph or glyph in the data is this, and you could deform a sphere, for instance, to become elongated or flat and so forth. So that's one way of thinking of materials and what they can do for you. So let's jump back in here into the my main editor here when I have this material. So maybe it's time to launch up my other level where I actually do have this material constructed. So we were looking at a material. So that's obviously something that allows you to define and how something's going to look like and behave. But I will then actually click on my material instance here and ask for reference viewer. And let's see if I hope you can see this. So you see that my material base here is having a material instance. And then there's a bunch of other instances. I will just regroup this to put like that. So I can see that my little mesh that I had imported here, it is using my material instance, DNA base master. And within a material instance, I hope I intended to, okay, maybe I need to right click, browse to asset or edit. Edit, there we go. So now we have my little super wiggly little mesh here. And this, you see, I don't have this node graph anymore. I can only change parameters of this material. And the way I structured this material now is using my DNA base. This is the real material, which is my parent, so to speak. And I can change that. For instance, I want all of my materials to be metallic. So I turn off the metallicness of this and see if it looks, you can see, maybe a little bit hard to see that it's metallic now. I'm just struggling to navigate here. Didn't have too much to show off the metallicness, maybe. Since we had this hierarchy, where was my reference view? There. At least in this view, you see the difference here on these spheres. By changing this parent, and all of my other materials here are based on this parent, I get a one place to change the appearance of all these materials. And now all of the ones following here are picking up my change at this level. So had I been deriving, or not deriving, had I parented my base material over here for each of these, and I wanted to make everything metallic, I would have to jump in on each and every one of these and change it to metallic. But I put in a master instance in between that allows me to change parameters of this one and all of the ones other follows. Well, let's save this metallicness for fun. So that was that. And then we are back to my level here again. Yeah, you see a big little thing here. You might wonder what that is. And this is part of my level sequence. And I have a camera crane and a camera mounted on that crane. So a couple of tools that makes it simpler to manipulate the camera and when I want to do animations to show up things. So that was the mesh materials and how I work with these. And this is my map here. This little guy here is actually just an enumeration. It's part of the blueprint concepts here. Well, maybe I should let you know here out in the world outliner up here, I have all the things that I've placed in this level. And here I only have one level, everything put into that. Normally, you would probably use a bunch of sub levels and you can turn them on and off as you are working on things. So actors are the core concept. So all of these are then made actors. Should I drag a mesh out into the scene? I don't have it in here. If I drag a mesh, it's a very small one. I get a static mesh actor, and that actor says that it holds this static mesh and it has this material. I am free to, let's maybe zoom in on that. Oops. Now my navigation is a little bit too fast. But there we go. There we have my material. And just see if I can get a little bit closer. There's the near clip plane picking in. So I can, per instance, if I placed an actor here that uses a static mesh, I can then reassign. I want this particular instance to use this material instead. And then it changes to that material. My base measure has a default material, but I can, using the actor here, I can actually assign custom materials or colors, so to speak, or custom materials to a mesh. And I can even change my static mesh here to different meshes, and I can pick up tons of other things that I've imported, for instance. So this leads into one actor here having one mesh. And how do I go from one mesh to thousands of meshes or tens of thousands of meshes? I don't want to create, first of all, no, not statically. Oops. I log out myself. Certainly not creating many of these up here in the world. I don't want to do it statically, and I want to add many of these objects. This way will create, there is some work going on and bundling and optimizing, having multiple objects like this, but it can end up with many draw calls, one for each of these actors, and that's gonna kill your performance. Draw count or draw call count, your number of draw calls in the scene is something you traditionally used to wish to keep low in any software, I would say, because that requires a complete setup of the rendering pipeline and all the parameters that you have for drawing meshes, and that can be costly. So that's where my little blueprint comes into place to allow me to not create specific instances of things, but actually create instances, not proper objects, so to speak here. So time to jump into my little blueprint. I'm just going to do a small check here on my side here to see if there are any comments or chats going on in the... Oh, seems to be okay. So here's the, let's see here where we are. I'm gonna get back to the starting point, which is my event graph. The event graph is kind of where things are driven from, various events. And I've done a few things here. This is not a particularly large scene graph or large blueprint, so to speak. But I do have a bunch of various functions that I've created within this blueprint. So let's just have a short, quick view over what this is. So at the top level here, there's an event tick. So this is something that happens on every frame. You can actually adjust the frequency, but if you don't do anything, it's typically gonna happen every frame. And something to be a little bit careful about. So that's why I actually do have some logic in here to disable it when I don't need to do anything. But that's more for the exercise in this case, rather than having performance issues in this tiny little application. But if you have thousands of objects with event tick here, that's thousands of things to check every frame, and you don't want to do that. Event begin play is otherwise a place where you start off doing things. So this is being called when your whole object has been spawned into the world, as the terminology is. Typically, if to you C++ guys out there, this doesn't mean a constructor is being called and all that. That's already done ahead of you. So you are just spawning pre-configured objects into the world in order to save both time and be more efficient. So with 20 years plus in the making, I would say pretty much all of the optimizations that you can think of has been done. Reducing memory access, memory allocations, constructor, destructor calls, and whatnot. Anyway, let's focus here. So I use the sequence here to just line up the things I want to have done. So this is just going to do one thing at a time. First this one, then 1, 2, and 3 in different steps here. And the first guy here is when I'm building the helix, I'm going to do this thing, but only for a number of times per. The count is set here to 2, so I will do 2 base pairs per draw call, or per frame, so to speak. And then I will allow it to continue the next frame. Same thing for adding components to the simulation. So this is taking out them from a hierarchical mesh and then putting into as a separate component to be simulated. Realize I'm going ahead of myself, so we need to look into a couple of things on how we are doing here. So these are keyboard inputs, so I've hardwired a couple of key shortcuts here, and that's okay to do for testing in my view, but you should rather define actual functions and methods and program your whole input system such that you can map different devices if you're on a gaming console or whatever you want to have functionality or semantics on what's going on here instead. Anyway, so maybe I need to mention here before that each of these blueprint actors, they have a default scene root or a scene component, which is really the base class, so to speak, for anything that has a transform in the world. And then I've added 4 subcomponents to this actor. So I have all the instances for my DNA base A and all the instances for DNA base C and G and T. And I have to use 4 different components here. You see that they're called hierarchical, instant, static mesh component. I have to use 4 different because an instant static mesh component can only have 1 mesh and 1 material, or 1 set of materials if the mesh supports multiple materials, which means I cannot assign that one T should be yellow and the other one should be green unless I have a material that somewhere picks up what color it should be from somewhere else by knowing its instance index or something like that. So in this scenario, I used 3 different ones. So the base T all use the, maybe I should can click on this and you can see that it can be set up by having a static mesh, and it can have, you should also be able to have a material assigned to that static mesh. You see, I have not assigned anything here because I want to do this programmatically. So I put my mesh as a variable. Let's see where it is, DNA based here. Basis here. So here I have assigned 4 variables. That's called mesh A, C, G, and T. They are references to a mesh, and they're all pointing to the same DNA. So when the day comes, I actually do have unique geometries for the different DNAs, or I have a way to create them. I would assign different unique DNA molecule meshes for each of these different ones. And I wouldn't have to rewrite this code a bit because it's all placed in variables that I can assign outside. Likewise, for the 4 different materials that I have, they are also assignable from the outside, as these eyes are indicating here. So if we're moving back out in the world, we can look at my blueprint DNA. I'll drag this out a little bit. These variables are now showing up here, so I can, per instance of this blueprint in the world, assign them different meshes and assign them different materials. If I'm jumping back into my blueprint here, we're gonna go and we can probably have this looked into. Not sure if I'm going through this, but this converts my string. So this is just a regular text string that has this chain of letters to represent the different base configurations. It produces a chain output, which is an array of my enum type instead. So I have an enum that actually defines which bases I have. Initialize my current position and my current build index. I enable the tick and I set that I am building the helix. So when I press B, this is going to enable my ticking up here. And that tick is then going to go through this. So all of these other guys are false. So it's only this that will be executed. And I'm going to build my helix partially. So I can jump into that code and see what it's doing, or function, maybe I should say. And I get some of the stuff in here. I have my base pair array, starting index, how many should I do, what's the starting position, and what's the direction I'm gonna increase and build my stuff on. So essentially just moving ahead the offset here. So I'm adding a certain number in the direction to increase my starting position here. Do a for loop over how many I should do, and then compute the transform, or how to rotate them across, like how the helix should look like. And then I'm adding a base pair instances. And since I have different types and all of these have different meshes, I have to say that I need to add, if I'm drawing a base A, I need to add an instance to this hierarchical mesh, plus an instance of T, because that's the combination of DNA that I can have. An A matches a T, and the T down here matches an instance of A. So that's how I then add instances. And the unique with instances, it's if you're into the OpenGL programming, you know about mesh instancing and how you have the same set of vertices. It's just reapplied over and over again, but with different transforms, so that you get many objects that are visible, but with just one single mesh. So let's see what happens if we are, we can delete this guy. And then we looking here to play. So here I have my little DNA strain or chain up and down here. And this one has been pre-built in a thing called the constructor script. But I should use space here now to dissolve my chain. And now they're all blowing away. I give them a random direction and rotation, and they don't have any gravity applied. So they're kind of just floating, and somehow they're just stopping in the air. I added my shortcut C here to clear off all of these, and now they're all gone. And I can press my B, and you're gonna see the chain building up again. So let's end that, and I think I'm just gonna quickly wrap up a little bit about this approach here, so we can get to talk about other things. Yeah, the construction script, this is actually building the chain and setting up the instances to begin with. So that's assigning the variables that I had here, assigning those to the different instance static meshes. So here I'm setting the meshes and then setting the materials for these different guys. The other part that I had in the construction was build the DNA chain, and this one builds the whole thing at once. So I just converting the chains, looping all over all of them, and then putting them in here. And this is essentially just such that when I go in here, I do have an object that would see, that I would see in this scene. Otherwise it would, if it's all built dynamically, I wouldn't see anything here in the level editor. Right, I think that was quite a lot of things to cover, and possibly a little bit complex to understand the first time you're looking at this. But the core principle here is using instancing as a mean to produce many or much of geometry that you dynamically can create and add into a scene at runtime, for instance. And you could also possibly convert or build a geometry as a procedural mesh and apply those at runtime as well. There's also a mechanism for you to take these materials and actually create a dynamic instance of them at runtime, so that you have control on setting various parameters on these materials at runtime. Otherwise, the parameters that we have here are defined as assets that are locked into. But if I want to be able to actually change those at runtime, I have to create a dynamic material instance, which I then can change the parameters on a per frame basis or whatever I want to do. So let's see here. I'm gonna try and see if I can find the right. I just want to check if there's any communication going on here on Slack or on the Zoom channel. But none that I see of window chats. Show chat. That's where I'm gonna go. All right. Thank you. I believe we had a break at 15:30, right? So I have a few more minutes to cover a couple of more things. So let's see in my cheat notes here. We covered some of the blueprints, parts, and assets, materials, plugins we didn't have a look at. But we should also look at material, C++ programming stuff. So I've actually gonna close this guy. We can have a look at this as well. I'm gonna make this font a little bit larger here so we actually can see stuff. This is from another project that we're currently working on, where we're looking at data, population data, and other things from the our Central Statistics Bureau or agency here in Sweden. To the left, let's see, yeah, that's where I have my implementation CPP file, and that's where I have my header file in here. So just want to go through a little bit about how does it look like. Programming in Unreal Engine is you are bound to follow their kind of style. You can of course compile up and package your own library and use that and link against and include that in your components or in plugins. So of course you can integrate whatever software or code you want. But for things that are actually going to be part of your thing, you want to probably stick to the things and that works for you. Specifically enabling things to show up and being used as blueprints, recompiling blueprints, and so it's like really fast, at most a second or something. Compared to compiling code and doing a hot reload, which works as long as you're not changing names and stuff. So to begin with here, there's a usual things here. What you'll notice is there's always this generated and stuff showing up for anything that you declare in here, specifically for the anything that's declared a U struct or a U class or so, which is a U object or not a U object, but an Unreal struct. It provides reflection code, saving, storing stuff, serializing all the parameters that you have that should be serialized. So I have a small struct here giving me a value range. It has a min and max value. And I'll say that these properties can be visible anywhere, but you can only read them in a blueprint or read only. Otherwise, you can specify read write. You would be able to actually write them from a blueprint. The generated body is something that's generated automatically. So Unreal has its own build tool, UBT, Unreal build tool, and it has a Unreal header tool, which go through your headers and picks up all these kind of things to encode and make things available and provide all the reflection API for you to use in the editor. So as long as you're following these standards and how to do things, stuff is working fairly nice for you. So I've also added an enum here that can be picked up, and I call that a blueprint type. Next, we have another struct here that I don't have any of these. So this is not going to be showing up. This is for my internal bookkeeping in my objects, more as a regular kind of thing that you're used to in C++ coding. And another of these internal structures here that I also use. Then I come to my actual class here, which is I call it U class. So that's a blueprint type. Can give it a display name. There's tons of more options that you can provide here as well. This is the project name API, and I derive this object from a U object. And U objects are a specific, is a base class, so to speak, for most of the things in Unreal objects here. But a U object is memory managed, garbage collected, can be clustered such that you're kind of destroying X number of objects at the same time in terms of memory and freeing up memory. And it has a bunch of different functions here to do things. The main object thing I do here is create a data view, takes in a couple of parameters, and as I might see when I scroll down a little bit here, it's a little bit more verbose. Well, I prefer that because all of these comments are automatically picked up, such that when you are working with blueprints and so when hover your mouse over it, it will tell you this. So this comment will be embedded as a explanation tooltip in the blueprint editor. I define that this is a read-only parameter, etc. Internally, also it uses a T array, and there's a T map, T set, and so forth. So all the templated kind of things you want to do. It doesn't use any of the C++ standard template library because they wanted to have control over these things in terms of memory management and really make sure they're optimized for the type of use you have in a game engine. Whereas the STL library in C++ is a more of a general purpose library. It doesn't really know the kind of use you want to do. So that makes it a flavor or version of C++, which is not exactly as you might have learned. So there's a lot of things to pick up and understand. And of course, the Unreal code base is huge by all means. Project installation is easily 10 to 15 gigabytes per version of your editor. Your project's content and of assets and things you import is not a big problem to rank up in the 1 gigabyte size of a project. So in that respect, I believe it's producing larger footprints than Unity projects do. So let's see, it looks like I'm having a couple of more minutes, but I'm just gonna, I do have a couple of more slides. I can certainly show you a little bit more of code, but maybe that's not, the purpose of this tutorial was not to give you a full-blown understanding of it. That's way too much. And for most people learning Unreal, I tell them that do not think of learning Unreal. You can learn Unreal to be a texture artist or environment artist, or you can be a developer of certain things in the Unreal Engine. But covering and knowing the whole engine is, I don't think anybody should probably have that ambition. So let's jump back here to that project and maybe just conclude with a few slides before I open up, I believe, for the Q&A. Yeah, we didn't look, we looked at the weekly material, didn't have a close-up look on the cleanup and dissolving a chain, but and the sequencer animation, maybe we should just have a quick look at that guy. So here's my sequencer animation here. And essentially I use my camera rig. I have the crane and my camera. I adjust my focus. I adjust my focal length so I can work with depth of focus, motion blur, not motion blur, but bokeh effects and so forth. And here my crane is moving up and swinging its arm around. I can select this camera here and let's see if, what should I do here? I should then select this guy here. I see this in here. I would change my viewport to cinematic viewport. And now I can play my animation sequence in here. Actually, no, I'm not going to do that. I'm going to use the Cine Camera Actor as well, so I get a view of how the actual cinema movie clip is looking about. So I'm moving the camera closer first here by shortening the crane arm, moving into fairly close, adjusting the focal length of the camera, and then continuing moving upwards with my little crane rig and so forth. A little bit overly long, looking at a very hacky, not a proper DNA molecule or DNA chain. Of course, you can add all sorts of animations and stuff you want to do here. And yeah, that's kind of the end of that. So let's move out of this and back to the presentation here. Right, so a few short notes here on the end here. Development experience. Yeah, I would say it's a steep learning curve, both in terms of understanding the concepts, how you work with things. But I really do like the notion of encapsulating an object, so to speak, an actor, both with meshes, animations, code to control behavior and what it can do. Mentioned that it's more of a dialect of C++. You can think of it, although it's pure C++, but without all the libraries, so to speak, or template libraries. They deal with their own memory management in a way and have garbage collection for the U objects. Compile times is longer. The header tool needs to kick in, produces all the generated files, etc. And I've come across a few students or colleagues that kind of want to be developed as a C++ developer. I would say C++ development in the Unreal Engine is get the job done, not get fancy C++ wise. And also using Git plus LFS, large file support. I would say it's been working fairly well for us so far. I have projects in the up above 10 gigabytes, and that's managed pretty well. At the university, we have our own Git enterprise server, so that certainly helps up. Otherwise, your limit is one gig, I believe, at the GitHub if you're not paying anything. A little bit of a summary here, just a few things. Of course, high performance, that's everything to it. High quality visuals. Unreal Engine is very feature complete. I didn't show you the list of plugins, but it's pretty long and it includes most of the things you need. The one thing we've added is a WebSocket library, or we had actually, now it's built in. A REST API we added as well in the project. But from a data visualization, I think we still need more visualization or data vis examples and data vis tutorials and more tools to be added and shared. And one effort that I've tried to done in that respect, although I haven't had the time to fully build up everything here, but we do have UE4 Viz as a tag or handle, both in WordPress, Instagram, Twitter, Slack, Facebook, and YouTube. So you can find stuff there. And there are some tutorials and some things that you can get there and get into. So let's see here. I'm diving into the Q&A session here, and I have one question from Noeska to everyone here. Thank you. When would you recommend someone to start developing a visualization technique in a game engine versus a dedicated visualization framework such as in Vivo? Good point. We're having that discussion among ourselves, since we have a in vivo is heavily developed at our group, or in our division. I would say one thing that we haven't done yet is like volume rendering, in terms of medical visualization and doing volume rendering. I've seen both volumetric simulations of smoke fire and then consequently rendering of that. I haven't dug into it myself deeply. It's a little bit more involved. So I think in vivo comes pre-packed and ready to do volume rendering. On the other hand, there are other things maybe that in vivo it's not embedded. You get a lot of things like playing videos, storytelling, sequencer animations, and so forth in the engine. Molecular visualization might be a different thing. That should be fairly should be possible to do, specifically looking into the Unreal Engine 5 forward here. I can render quite a lot and use the mesh shader for doing rendering. Hard question, but as we go by, maybe we have more and more plugins and support for doing specific things. Yeah. Any more questions, or Michael?
Or channel. I might just read them out to you.
Yeah.
So the first one. Oh, and by the way, we should of course thank you first for the amazing tutorial talk. Thank you very much.
Thank you.
So yeah, David Gilbert was asking, was curious about the N-display setup that you showed in the beginning. This dome N-display.
Right.
And he asks whether it's a Linux or Windows cluster that's driving this one.
Windows.
Would it also be possible using Linux, or was that just an arbitrary choice?
No, we run our cluster on Windows for the other applications that we run. So it's fairly standard, I think, to run it at Windows. I can definitely give you a more detailed answer. There are things going on in the OpenGL API where, well, you need a quadro card to have proper gen-locked syncing of all the projectors and the rendering output, so you get really hardware support for the synchronization between displays. On top of that, you need also to work with the software side of making sure that all your texture streaming stuff is done concurrently and simultaneously on the different projectors, of course. So I can certainly forward you more complicated questions to our my CTO runs the. Let's see. Let's check if I'm on the right Cord channel here. Discord, I mean.
So yeah, another question asked on Discord. I just also posted a link to Discord. Is whether there are any specific examples using Unreal for data visualization. So I guess the question is how you can get specific scientific data formats, data file formats that you also talked about into Unreal. So compared to like VTK or so, or in vivo, like Niska asked, where you can just load these scientific data formats, how do you get them into Unreal?
Yeah, that's one of my kind of need to do things in a way. I've been discussing it a little bit with some folks at VTK, but how would you go about it? I've seen some various integrations. There's been an integration with VTK and Unity, but essentially at the frame buffer level, which I think is not sustainable or your desired way. So there are some ideas on how you would proceed, but actually having a plugin and allow you to actually run VTK code, but you would have to rewrite the back end of that. So you produce your mesh and data and make them first class kind of Unreal meshes and objects that can be rendered and allow that rendering engine. I'm probably not gonna be able to push forward that myself, but the idea is really to gather a bunch of people that would kind of know how to do it and apply for funding from the Epic mega grants. So they have set aside over $100 million for various projects, and I think that would be an excellent project to kind of put together and do it.
So I guess the next question also a bit relates to this. So, and also what you showed, that you have this example page. So are there good examples using dynamic geometries inside Unreal?
Yeah, so one thing that I show you in this network visualization that I had in somewhere, I can just get back to this slide here. So this part is actually, this is a compute shader producing these meshes. They're really tubes that you can render out and get the proper stereo perspective in an HMD experience, for instance. So this is done dynamically, so to speak. And we've continued this work a little bit, struggled a bit. They rewrote the rendering backend primarily for adjusting it and support the ray tracing API that has to keep geometry and push the meshes and stuff to the GPU in a different set and optimize it for that use case. So we've adopted that, but then we didn't have time to proceed. So we might get back to this and have a spline rendering kind of plugin to visualize stuff and do this dynamically. And we had, I think we were able to produce something or render in the order of 60 million spline segments per second, pretty much maxing out the bandwidth between the producing the actual data to render and rendering it. I don't know. So that was one case.
Sorry. I was just about to say, I'm sorry, but I think you're running a bit out of time.
Yep.
It's a virtual meeting, but still, I guess some people might want to get a coffee before the next part, the part about Unity 3D engine starts. So I hope, Patric, you will be around a bit more and also might have a look into the Discord channels for more questions. So
yep, I will browse through that. And
only benefit, so to say, of a virtual conference, well, one of the two big benefits, people from all over the world can participate more easily, and you can answer questions offline more easily, right?
Yep.
So yeah, Discord channel is of course open all the time for more questions. And yeah, with this, as I said, I would say we should thank Patric again.
Thank you, and thanks for the opportunity.
It's very interesting for me, at least. And yeah, now we have half an hour coffee break. Afterwards, Xavier Martinez will give the introduction to Unity, as I said. And I'm not sure, our technicians might throw people out of the Zoom channel in the coffee break. I'm not sure about this. If they do, please come back after the break for the second part of this. So thank you.
Thank you.